Chapter 18 is the last chapter in this course, and the topic is the economics of the environment. So economists approach the study of the environment differently than a lot of other scientists and other individuals do. And of course we use our tools of supply and demand and incentives and marginal thinking in order to come up with policies for reducing pollution. But it's not necessarily the goal to get pollution down to zero, and the title of section 1 of this chapter highlights that. So this section is titled Maximizing the Net Benefits of Pollution. And so some environmentalists might hear that and think, why would you want to maximize the benefits of pollution? But the answer is, we produce pollution as a byproduct of doing things that bring us utility, or producing things that we sell to make a profit, right? So you drive, you take a road trip, and you produce some vehicular emissions. So if we require pollution to be zero, then no one can drive, in fact no one can even exhale, because when you exhale you breathe out carbon dioxide. So to say that pollution should be zero, to an economist, exhibits a lack of understanding of marginal thinking. So let's get into this section. Here we're going to talk about the nature of benefits and costs of pollution, and review the concept of marginal benefit and marginal cost, which we saw originally in chapter 6. So we'll have to reach back into that chapter for some refresher. And then we're going to talk about this important idea called the Coase theorem, named after an economist who recently passed away, but he's a Nobel Prize winner named Ronald Coase, and I'll say more about him when we get to that part of this section. There's a definition of pollution here, and that says it's a situation that exists when human activity produces a concentration of a substance in the environment to cause harm to people. And so what I'm trying to highlight here is that it's anthropocentric, which is a term that means human-centered. So in this perspective, we care about the environment because we enjoy the environment, right? We like having a clean environment, clean air to breathe, and so on. Now, there are other perspectives, some environmental perspectives, ecological perspectives that say we should preserve the environment in and of itself. Even if we are never going to go even if we have no benefits from the environment being clean, and no future generations will, we still have to preserve it. We have a duty to the earth. That's not the perspective of economics. You could have multiple perspectives, but when we're looking at the world through the economics perspective, we're thinking about it as an anthropocentric view. This is figure 18.1, and it's titled Determining the Efficient Level of Pollution. And so here the example is, we have two individuals who pollute. They have a fireplace in their cabin, and they burn wood, and then that wood goes up in the chimney and out, and downwind there are two other people who have cabins, and they suffer the consequences of that pollution. You might think about it as the downwind people have laundry hanging on a line, and when the smoke comes it makes their laundry dirty, and once in a while they have to rewash it. Or maybe they even have a laundromat professional service, so it really harms their business. You could think about this type of situation. And so the costs, let's start with the costs. For an individual, are given by these orange curves. So there's an individual named R, I think his name is Rob or something, and then Sam. Anyway, Rob has a lower cost, so maybe he doesn't do as much laundry. And if there are 34 pounds of pollution being produced, he suffers a marginal cost of 4. That means that 34th unit of pollution cost him $4. Maybe he had to rewash the laundry, and it took him $4 to do that. But notice he was harmed all the way from the 5th unit, right? The first 4 units of pollution he didn't even notice. But the 5th unit caused a slight amount of damage that he noticed, and then as the pollution increased, the damage increased. So the total area under this curve is his total cost, but this is the marginal cost. And if you go back to chapter 6, I think it's figure 6.1, we'll go back and review it in a moment, you'll see the difference between total cost and marginal cost and total benefits and marginal benefits. So let's review that. This is figure 6.1. I know you can't read any of the writing here, but you can see the figures. The top figure is total benefits, and quantity is on the x-axis. So we have total benefits and Q. And notice this curve, this looks like, has this shape. So it's increasing, but it's increasing at a decreasing rate. So at first the slope is 20, and then the slope is 14, and then 10, and so on. So the slope is getting flatter, right, as we move along. This is the property of diminishing marginal benefits, right? As you consume more and more of something, you continue to benefit, but the additional consumption gives you less utility. And so then, because the marginal benefit is just the additional benefit you get from consuming one more unit, it's the slope of this curve. And then we can draw this curve like so. So you can review that. And here's really the figure that I wish we had in the book. So we have a total benefit curve just as before. And in fact, I'm going to label this just dollars because these are measured in dollars. And I'll label this curve total benefit. Now, we also have a total cost curve. So whereas total benefits increase at a decreasing rate, total costs increase at an increasing rate. The idea is, as you expand, say you're producing this Q, your costs go up. But eventually you run into the too many cooks in the kitchen problem, as I call it, and your costs get really high. So if you want to produce one more unit of output, it's going to be really expensive because you've already got so many people crammed in your kitchen. So for example, so let's say we have this quantity going here from 0 to 10. So what does it look like? What quantity does it look like would maximize net benefits? Net benefits being total benefits minus total costs. What quantity?
7-ish.
It looks like about, yeah, right around here, right? Some people, I'm glad that you got that because we already covered this in chapter 6, so you didn't forget. That's good. Many people say, oh, right here, because these were the curves intersect. No, not true. Right here, total benefits equal total costs, so therefore net benefits are 0. So we want to maximize the difference between them, right? And so that occurs wherever the difference is greatest. Now, right below this curve, I want to draw the marginal benefit and marginal cost curve. Remember, the marginal benefit and marginal cost curves are the slopes of these two curves above. If net benefits are maximized here, let's say this is at 5, it turns out this is where the marginal benefit and marginal cost are equal. And let me show you why that is. Again, the slope of these total benefit, total cost curves are the marginal benefit and marginal cost. The slope of the line right here is equal to the slope of the line right here. That's a mathematical fact. And let me just highlight that here. This is supposed to be tangent. And this is tangent and has the exact same slope. So it's a very interesting property, mathematical property, that where net benefits are maximized, the slopes of these lines are equal. And because the slopes of these lines are the marginal benefit and marginal cost curves, they're equal where net benefits are maximized. Okay, so that's a refresher about why net benefits are maximized when these curves are equal. We get the biggest difference between benefits and costs where these curves are equal. The other person, Sam, call him, has higher marginal cost. So at 34 units, the marginal cost is 9, and his total cost is the area under this curve. The total cost for everybody is the area under both of these curves, and the marginal cost for both of them is the sum. So we must go vertically here. Why? Because the pollution is an externality. It's almost like a public good, right? Once it's out there, if somebody consumes it, it doesn't go away, right? It stays there. So however much is there, we harms both of them, and then we consider the marginal cost for everyone like that. So for example, at 34 units of pollution, we have this person harmed at 4, this person at 9, together at 13. So this is the total marginal cost curve. Here, it's similar, but we sum the curves horizontally. The reason is because these people are consuming an externality. They don't want to consume it, but they're consuming an externality. But these people are producing the pollution. And the more pollution that's produced, the more is added to the total pollution. So for example, this individual gets a benefit of polluting. Now, it's not that they enjoy polluting for polluting's sake, right? But they get warmth from their fire, maybe they're cooking on it. And so, if it's really cold, and you put a log in your fireplace, that feels really good, right? You might be willing to pay, $20 for that. So that would be somewhere up here for the very first unit of pollution produced. The benefit is huge, because it's freezing cold in your cabin. Then you throw another log in there, and you get warmer, so you're happy, but the marginal benefit is lower, right? So the marginal benefit's falling. This is the law of diminishing returns, right? Finally, you're really toasty. And so you put another log in there, the benefit's not so high, so we're down here. Okay? And to find the total benefits, we sum up these two marginal benefit curves, and we get this marginal benefit curve for society. We're considering only 4 individuals in this society, right? 2 polluters and then 2 people who suffer from that pollution. So these are basically demand and supply curves, right? We saw in the production and the perfect competition chapter that the marginal cost curve is the supply curve. And the marginal benefit curve is the demand curve we saw earlier in chapter 6. Put them together, we find that where are net benefits maximized? Well, at the point where demand and supply intersect, right? If we produce, if 60 pounds of pollution are produced, then we have this whole area under the curve of benefits. But what are costs? Well, it's the entire area under the marginal cost curve. First of all, these cancel out, right? So these are benefits minus costs. These are 0 then. So we have benefits over here and then costs over here. To calculate the net benefits, we have to subtract this red area from this blue area, and we'd have some kind of small area, probably these 2 lines only. But if we reduce pollution to here, the equilibrium, or I should say the efficient level, these costs are eliminated. These costs are not eliminated. So these benefits were eliminated. However, all these costs were eliminated. So again, these cancel. But we have this larger area of net benefits now. So that's why net benefits are maximized at this point. Okay, so let's return to figure 18.1. So the problem might be, however, that the 2 people with fireplaces burn more logs and produce more than 34 pounds of pollution. In fact, if they don't pay a price to burn wood, other than the price of the logs, right? They don't pay a price to emit smoke. They probably will keep burning until their marginal benefits are 0. Until they get no more benefit at all. Until their cabin is so toasty that putting another log in the fire would actually decrease their utility. So they would probably consume to here. And so really the fundamental question of this chapter and of environmental economics altogether is, how can we get pollution to here? And we're going to consider a variety of approaches in the next section, including regulation. Require the people with fires to not burn more than 34 pounds, to produce not more than 34 pounds of pollution. Another possibility is we can tax polluters. If we set the tax at $13, then they'll produce 34 pounds and we'll be at the efficient pollution. We could have a permit system. And the opening part of this chapter describes a carbon dioxide permit system. I'll talk more about this in the next section. But basically you allocate permits to the polluters and say, this is how much you can pollute. If you want to pollute more than that, you've got to buy more permits. So it's similar to a tax, but there's important differences that we'll discuss. And then another and final possibility that we'll discuss is called moral suasion. So maybe the society can use some informal types of social ostracism or other punishment, basically criticizing polluters. Or maybe you can just ask them nicely, hey, can you not pollute so much? And maybe that will work. We'll talk about this next. But there is one other option, and this gets us to Ronald Coase, who I mentioned at the beginning of this section. So you have to be a pretty important economist to have a theorem named after you. And the Coase theorem is named after Ronald Coase. Okay, the definition of the Coase theorem is the proposition that if property rights are well defined and if bargaining is costless, then the private market can achieve an efficient outcome regardless of which of the affected parties holds the property rights. Okay, so the issue is, the main implication of this is, society needs to allocate rights, or property rights. In this case, it's the right to pollute, or the right to have clean air. So which is it? Do the people with the fires have the right to pollute, or do the people with the laundromats have the right to clean air? Which is it? If we don't specify it, things aren't going to work well. But as long as we specify it, things will be efficient. And here's the key insight of the Coase theorem. It does not matter who gets the rights. Because either way, they're going to bargain with each other and reach the efficient outcome. Now, remember, economic models rest on assumptions. One assumption here is that bargaining is costless. If these two parties speak different languages, then bargaining clearly is not costless. Right? If there are millions of individuals and we have to coordinate among all of them, bargaining is not costless. So, assigning property rights and allowing bargaining, or basically the free market, to work is not going to work in all situations to achieve an efficient outcome, because bargaining is not always costless. But if it is, it can. And this type of thinking has led economists and policymakers to adopt a wide variety of policies, including the permit policies that I've mentioned and we'll talk about more. And so Coase has had a tremendous influence on our everyday lives. But let's go back to this figure now and see how this, think about how this bargaining would work. So remember, the key to the Coase theorem is that property rights have to be well defined. It doesn't matter how they're assigned, but they have to be assigned to someone. Let's say they're assigned to the people with the campfires. So what pollution level are they going to choose? Well, they can do whatever they want. They have the right to pollute. So they're going to burn firewood until their marginal benefit is 0, so 60 pounds of pollution. But the people with the laundromats experience a very high marginal cost, right? And so they have an incentive to walk over there and say, hey, would you guys consider lowering your pollution? Maybe they try moral suasion first, right? But if that doesn't work, they can get their pocketbooks out and say, look, I'm going to pay you. Your pollution is damaging my business so much that I'm willing to pay you to reduce your pollution. And so if you pay them $13 for every pound of pollution they reduce, they're going to reduce all this pollution up to here, right? Because their marginal benefit of these 34 through 60 units of pollution is less than 13. So they'd rather have $13 than pollute this much. So they will. So they'll reduce their pollution to here. Bam, we're at the efficient outcome. Now, what if, on the other hand, we allocate the right to the laundromats? In other words, they have the right to clean air. So they're going to say, look, no more campfires, no more fireworks, right? 0 pollution. What's the problem then? Who's upset? These people are sitting in their cabins freezing. They're going to say, look, we're really cold. Will you please let us have a fire? We will even pay you $13 for every pound of pollution that you allow us to emit. And these laundromat owners are going to say, sure. Because for the first few pounds of pollution, we don't even notice. Right? We don't even notice the pollution. Marginal cost is 0. And then even it's quite low up until here it starts to rise. By this point, we're not going to allow you to pollute anymore because our costs are higher than $13. But you can pollute up to here. And again, we'll get the efficient outcome. So it doesn't matter. Bargaining will, if it's costless, get us to the efficient outcome. That's one of the unique insights of Ronald Coase. And it has the name, the Coase theorem. This last section is on the measurement of benefits and costs. And this is an empirical problem. So we have studied scatter plots, right? And we know how to estimate, how to fit curves to data. And so one way that you could estimate a demand or supply curve is to go out there and find quantities and prices, right? Find markets and find the prices and quantities that are associated with those markets. So you get a point. Go to a different market and see if the price is lower, what quantity do they consume? And so then you look at that. And so you can get all these points together. Actually, they would look like this, wouldn't they? Because it's a demand curve. Downward sloping, right? So you have all these points. You fit a trend line in there, and you have a demand curve. The problem with environmental goods, however, is that we don't observe prices and quantities generally. And so we have to use more clever methods. And let me talk about one easy to understand method, and then I'll talk about a more difficult to understand method. The first easy to understand method is the survey method. Economists like to give fancy names to things, and they call it contingent valuation. But basically it's a survey method where you ask people, how much would you be willing to pay to clean up the pollution? So this is getting at the benefits of clean air. As this chapter discusses, the benefits of clean air are the same thing as the costs of pollution, right? And likewise, the benefits of pollution are the same thing as the costs of abatement. But let me just continue with this survey example. So there was a survey done in Colorado. They were thinking about cleaning up the South Platte River, which was very dirty, polluted from agricultural pollution and urban pollution. So the river was dirty, and they were thinking about cleaning it up. And they want to know, is it going to yield benefits to people? Remember, this is an anthropocentric view. So if it's a benefit to the fish, that might be nice, but we're not considering that. The only benefit is if people are willing to pay. Maybe the people are happy if the fish are happy and they're willing to pay for that. But then that's the only time it's a benefit. So we asked them, how much would you be willing to pay to clean up this river? Now, turns out you have to be a little more careful than that. Because some people will say, $1 billion. We know that they don't even have $1 billion, right? So we have to make it a carefully worded question. And there's a long literature about how to ask careful survey questions to get truthful responses. And some economists are skeptical of this approach because it's a stated preference approach. You're stating how much you prefer things rather than actually revealing them in markets. And I'll distinguish between these two in a moment. But this is one kind of easy to understand way that we could measure the benefits of clean air or the cost of pollution, however you want to look at it. This case in point article describes a study that takes a totally different approach to measuring the costs of pollution. They use housing price data to measure the costs of pollution. So what they did is they gathered data on housing transactions, right? So they calculated, they found out the price of the house, price it was sold at. They also know how large the house is, how many square feet, how many bedrooms it has, how many acres the lot is. They know a lot about the properties, including the price it's sold at. And then they also know how close is it to a hazardous waste site. There are hazardous waste sites all over the country, including in San Jose. We have one by our south campus near the football stadium. There's a Superfund site, so a very hazardous waste site down there. And all over the country there are hazardous waste sites. Do you think property values are higher or lower if homes are close to hazardous waste sites? Should be easy, right? To say, we think they're going to be lower. Maybe you're going to get sick if you're close to a hazardous waste site. Or maybe you won't, but you just think that you will. So there's just a negative perception associated with it. In any case, people are willing to pay less for homes that are near hazardous waste sites. And so they calculated how proximity to a hazardous waste site lowers property values. And then what can you do? You can imagine we clean up this hazardous waste site, so therefore you're no longer near it because it's cleaned. Your property value is going to increase, and we can estimate by how much it will increase. And we can take this as a measure of the benefits of clean environments. This is called the hedonic pricing method. It's another strange name that economists give to techniques. I probably would say it's the property value method. And if you take a class in cost-benefit analysis, we have one here and I teach it, You'll learn how to do these survey techniques and hedonic pricing techniques. But let me ask you one thing. We learned earlier, correlation does not prove causation. Is there any reason why housing prices might be lower closer to hazardous waste sites? Despite the, that has nothing to do with the fact that the hazardous waste site is causing the property prices to be lower? Yeah. Yeah, good, I like that. Any other ideas? So, to put what you said slightly differently, this hazardous waste site might be near a bunch of other industrial properties. So you have a bunch of industrial properties. One of them turns out to be hazardous. But the reason that the property value is lower is not because it's near a hazardous waste site, it's because it's near an industrial site. People don't like to be near industrial sites either, right? So it might not be the hazardous waste site causing it. Therefore, if you clean up the hazardous waste site, property values may not rise as much. I know that David Brasington is a good economist. We had the same advisor at Ohio State. So he must have addressed that in his paper, but we have to read it to figure out how they addressed it. I have read another paper that's similar to this, and what they did is something very interesting. To get around this correlation-causation question, they looked at a situation where the Environmental Protection Agency announced hazardous waste sites. So nobody knew they were hazardous, but they were announced all at one time. They put out this list, and then everyone's like, oh, there's a hazardous waste site right next to my property. And they were able to take advantage of that fact to estimate the same type of model that predicts housing prices based on distance to hazardous waste sites. And they found that before this list was announced, yeah, being close to a hazardous waste site that nobody knew about did lower property values a little bit. But once people knew it was a hazardous waste site, it lowered property values a lot more. And so this is a clever empirical strategy that to try to demonstrate more carefully that it's actually the hazardous waste site causing property values to fall. And so this is a great example of the type of research economists are doing, the type of empirical research that economists are doing. And it has a direct relevance to environmental economics here, but also many other topics.